Let's take a look at spectrum monitoring with your real-time spectrum analyzer. Great place to start for many spectrum monitoring applications is to get the lay of the land by sweeping the entire span at high speeds. Sweeps as fast as 1 millisecond capture many signal artifacts over time. We use a max hold trace to track these signals and use the peak table to identify individual bands. When a signal or band is worth deeper investigation, we can switch to real-time mode for further analysis. In real time, let's look at a part of the 2.4 gigahertz band. This span is overrun with Wi-Fi and Bluetooth signals, as well as occasional short-duration, high-power pulses. Here we start with a wide RBW to capture the short pulses more accurately. We can switch to density spectrogram, and you can see the pattern of these pulses in time on the spectrogram, even though they're obscured by the Wi-Fi signals when on the right side of the analyzer. You can switch to a lower RBW, and now you can better separate the pulses across the band because the power is more concentrated in frequency than the Wi-Fi signals. There are several ways to further isolate the signal. First, we can trigger on the power level. Because the signal is sometimes still completely obscured by the Wi-Fi transmissions, this isn't the best way to capture this signal. With a frequency mask trigger, on the center, we can capture just the pulses of interest and separate them. We can then zoom in on the span to get a closer look. Now, we can see the indications that this signal is pulse modulated. We can use a wider span and higher RBW to more accurately capture the power with a lower 100% probability of intercept. Zoom in and use tighter RBWs to more accurately visualize this signal frequency and determine the modulation characteristics. With the signal isolated, we can switch to BVT spectrum to look at the signal timing. Here, we can see the pulse in the spectrum at the bottom of the display. On the power versus time chart at the top of the display, the 10 microsecond pulse is triggering at the very left end of that window, while the other Wi-Fi and Bluetooth signals appear asynchronously throughout the captured time data. It's a great way to use a couple different views and techniques to monitor spectrum with a real-time spectrum analyzer.